In order to find a common denominator for each pair of fractions, we want to make sure that the denominators, or the bottom numbers, are the same. The way that we can do that is we can figure out what number both denominators go into. For example, what number does 3 go into and what number does 9 go into. A simple way to do this first problem for number 1 is to realize that 3 goes into 9 3 times. So I could multiply both the top and the bottom by 3 to get a common denominator of 9. I can also determine common denominators for number 2 by thinking, what number does 6 go into that 9 also goes into? What factor do they have in common? I know that 6 and 9 both go into the number 18. 6 goes into 18 3 times, 9 goes into 18 2 times. Another way that I can find a common denominator is to multiply the denominators by each other. So for example, I would multiply 3 times 5, and of course I would do that to the top as well, and I would multiply 5 by 3. This way, we are multiplying the denominators by each other to find a common denominator of 15. We can do the same thing for 3/10 and 4/7. We can multiply the denominators by each other. That way, we can have a common denominator of 70. In order to rename the following fractions as whole numbers or as mixed numbers, I need to think of a fraction as a division problem. So this would be 56 divided by, think of this line as divided by, 8. In other words, I'm trying to figure out how many times does 8 fit evenly into 56. 8 fits evenly into 56 7 times. So in this case, I can rename this fraction as a whole number of 7. For number 6, I need to determine how many times does 5 evenly fit into the number 31. I know that 5 times 6 equals 30. If I multiply 5 6 times and I get 30, that means from 31 I would have 1 left over, and my fraction is over 5. So I can rename 31/5 as 6 1/5. For number 7, I need to think of this problem as 18 divided by 4. I need to determine how many times 4 fits evenly into 18. I know that 4 times 4 equals 16. So if I multiply this, 4 can go into 18 4 whole times. Then I have a remainder of 2. And if I'm putting this into simplest form, I know that I can divide each of these sides by 2, so my fraction in simplest form would be 4 1/2. For number 8, I'm essentially thinking 6 divided by 1, or how many times does 1 fit into 6? I know that 6 divided by 1 equals 6, so as a whole number, I can rewrite it just as 6. When writing fractions as decimals and percents, if I'm trying to get a fraction to a percent, I want to make the fraction out of 100. Any number out of 100, you can get a percent sum from. So example 75 over 100 would be 75%. In order to get my fraction with a denominator of 100, I need to multiply each side by 25. When I do this, I get a fraction of 25/100ths, or 25 over 100. Looking at my example up here and knowing that 25 over 100 is the same as 25%, I can get my percent. In order to get my decimal, I need to think of a percent as a decimal, so 0.25. Again, you can think of it as 25/100ths, just like over here would be 25/100ths. Now again, I need to get, for number 10, I need to get a denominator of 100. I know that 5 goes into 100 20 times, so I can multiply both the numerator and the denominator by 20. This way I would get 80 out of 100. 80 100ths is the same as 80%. 80% or 80 hundredths is the same as 0.80 or 80 hundredths. For number 11, my fraction is already out of 100. So 29 over 100 is the same as 29%. And as a decimal, that's written like this. For number 12, I again want to get a denominator of 100 to make it simple. 24 times 4 equals 100, so I multiply the numerator and the denominator by 4. I would get 32 over 100, or 32 hundredths. That would be 32% or 0.32. To determine which fraction is greater for each pair, I need to determine whether 2/3 is greater or whether 2/9 is greater. The way that I can do this is I need to think about whether, since my numerators are the same, 2, I'm essentially thinking that something is broken up into 9 different pieces and something's broken up into 3 different pieces. If I have 2 of the 9 pieces, that's going to be smaller than if I have 2 out of something that's split into only 3 pieces. I can also cross-multiply to determine which fraction will be greater. Notice I'm putting arrows to show you the direction that the multiplying will go. If I multiply 9 times 2, I get 18. 3 times 2 would be 6. In this case, 18 would be larger than 6, so this fraction is going to be larger. For b, I can cross-multiply again. Neither the numerators nor the denominators are the same, so cross-multiplying is the best way for me to figure this out. 6 times 4 is 24, while 7 times 5 is 35. Since 35 is larger than 24, 5/6 will be my fraction. For c, I can cross-multiply again. 11 times 17 is 187, while 21 times 9 is 189. So in this case, 9/17 would be larger. The reason this works is because thinking about trying to find common denominators, when we would find a common denominator, for example, we would multiply 9 times 3 and 3 times 9. When we do this, we would get 18 over 27, or 6 over 27. As you can see, these numerators match the numbers that are on top here. We're just doing it in a quicker way as we cross-multiply. Either way, this fraction is larger. And again, that works for all the other fractions as well. If I'm multiplying these denominators by each other, I would multiply each side by 6 and each of these sides by 7, and I would get 24 and 24 over 42, or 35 over 42. Again, this fraction would be larger. If I'm and you could do that for any of the problems just to check, but that's why cross multiplication works. For number 14, is 11/25 greater or less than 1/2? It would be less. And the way that I can figure this out is I can turn 11/25, I can find an equivalent fraction that will help me see easily whether it's more than half or less than half. If I multiply each side by 2, I would get 22 over 50. I know that 25 over 50 would be 1/2. So 11 over 25, or 22 over 50, must be less than 1/2. In order to list the following fractions in order from smallest to largest, I need to first use some reasoning to figure out which fraction I'm going to start with. When I look at all of these fractions, what jumps out is that 4/9, 5/8, and 2/5 are all pretty close to 1/2. This is almost 1/2. This fraction, 5/8, would be larger than 1/2, and 2/5 is almost 1/2. And I know that because half of 8, for example, would be 4. Half of 9, for example, would be 4.5, and half of 5 would be 2.5. So those are pretty close. I notice that I have fractions that are smaller than 1/2. So I'm going to start with one of those. But I'm not sure whether 1/3 is smaller or whether 3/12 is smaller. I'm going to find a common denominator so that I can compare the two. If I multiply each side by 4 for 1/3, I would get 4/12. If I compare that to 3/12, I can clearly see that 3/12 would come first. It's smaller, and 1/3, or 4/12, would come next. Now that I've finished those, I need to determine which of my almost 1/2 fractions are the smallest. In order to do this, I can cross multiply is one way. Again, I would just be multiplying the denominators by each other. So if I cross multiply 2/5 and 4/9, 2 times 9 is 18. 5 times 4 is 20. This fraction would be smaller. Again, I could have multiplied the denominators by themselves, and I would have found the same thing. So next in my order would be 2/5. Right after that, since I know 5/8 is larger than 1/2, will come 4/9, and since 5/8 is the only fraction that's larger than 1/2, that would be the largest fraction available. In order to add and then write in simplest form, I'm going to first look at my denominators to make sure that they are the same or like denominators before I start adding. In this case, they are both 7. So I can simply add 4 plus 3 is 7 over 7, 7/7, and 3 plus 4 would be 7 for my whole number. Now this is a mixed number, and I know that 7/7 is the same as 1, so I can actually rename this as 8. For B, I notice that my denominators are not the same. In order to make them the same so that I can add them, I can multiply the numerator and the denominator by 2. This way, I would get 1 and 2/4, which is equivalent to 1 1/2, plus 4 and 3/4. Now, I can add my numerators, 2 plus 3, 5/4, and now I can add my whole numbers. 1 plus 4 is 5 and 5/4. However, I notice that 4 can go into 5 one time, and there's going to be a remainder, so I need to rename this fraction in simplest form. 4 goes into 5 one time, so I'm going to add 1. 6, 4 goes into 5 one time, and there is 1 left over. So I have 6 and 1/4 as my answer. For C, I notice that they also do not have common denominators, so I'm going to multiply the denominators by themselves, by each other. So here I would have 2 and 4/12 plus 3 and 3/12. Now I can go ahead and add my numerators. 4 plus 3 is 7/12. 2 plus 3 is 5. So my answer is 5 and 7/12. For D, again, they do not have common denominators. Going to multiply the denominators by each other. And of course, whatever I multiply the denominator by, I must also not multiply the numerator by. So here, my new fractions are, my equivalent fractions are 6 and 25/30 plus 3 and 18/30, which I can add to get 9 and 43/30. However, I recognize that 30 can go into 43, so I need to rename this in simplest form. 30 goes into 43 one time, so I'm going to add 1 to my whole number. The leftover would be 43 minus 30, and I'm left with 13. So my remainder is 13/30. My answer in simplest form is 10 and 13/30. Subtracting fractions is very similar to adding fractions. I notice that I have like denominators, so I don't need to change anything before I can go ahead and subtract. I'm going to subtract my numerators, so 5 minus 2 equals 3, and again my denominator is 8. 7 minus 2 is 5, so my answer for A is 5 and 3/8. For B, I notice that 10 and 3/10 minus 5 and 7/10, we run into a little problem because 3 is smaller than 7, so I can't subtract 7 from 3. I need to rename this fraction to make this problem doable. So I can borrow just like I would in normal subtraction. I can take 1 away from 10 and make it 9. Since our denominator here is 10th, we're dealing with tenths. I'm going to be adding 10, whatever my denominator is, to my numerator because 10 tenths is the same as 1. So my new equivalent fraction would be 9 and 13/10 minus 5 and 7/10. Now the subtraction problem looks a lot more familiar and it's very doable. 13, and I'm going to put everything over 10, 13 minus 7 is 6, and 9 minus 5 is 4. I notice that this is not in simplest form. I can divide each side by 2. So in simplest form, my answer would be 4 and 3/5. When we multiply fractions, we can think of it as multiplying the numerators together and then multiplying the denominators together. 5 times 1 equals 5 over 4 times 6, which is 24. So 5/24 would be my answer. For B, I can multiply the numerators together and I get 7. Multiply the denominators together, 24. So my fraction is 7/24. For C, same thing. Extend and multiply the numerators. 3 times 2 is 6. 5 times 3 is 15. I know that I can simplify this because 3 is a common factor. 6 divided by 3 is 2. 15 divided by 3 is 5. For D, in order to multiply these, I need to turn them into improper fractions. They are currently mixed numbers. Again, the way I do this is I multiply the whole number by the denominator because the whole, in this case, is out of 2. So 1 times 2 is 2, plus my remainder, which is 1. my fraction is 3 halves multiplied by 2 times 2. I'm multiplying the whole number of 2 by the denominator of 2, what it's broken into. 2 times 2 is 4, plus 1 is 5. So my new multiplication problem is 3 halves times 5 halves. And then I can multiply the numerators, 15, and multiply the denominators, 4. I know that I can rewrite this number as a mixed number to make it into simplest form. 14 goes into 5 evenly 3 times. I know that 4 times 3 equals 12. So if I take 15 and subtract 12, I can find my remainder of 3. And it's over 4. So my answer in simplest form, 3 3/4. For E, again, I need to turn my mixed number into an improper fraction. 3 times 4 is 12, plus 1 is 13. Fourths, multiplied by 1 times 3 is 3, plus 2 is 5. Thirds, if I multiply the numerators and the denominators, I get 65 twelfths. I know in order to fill in the missing number, I need to keep in mind that I'll be renaming these fractions to be equivalent, because this equal sign means that whatever this fraction equals, this fraction must also equal. So if I start off with a 4 here, and over here I only have 3 units, I need to determine what is going to be in this box that added all together would equal 4 4/6. I know that if I had to take away, just like when we do subtraction, if I took away 1 whole and I was left with 3, just like it says that I'm left with, I need to figure out where that 6/6 went, because remember that equals 1. So if I take away 1 from here, this 6 over 6 needs to go somewhere. So I would add it to my numerator. 4 plus 6 is 10. So 3 10/6 is equivalent to 4 4/6. Let's try B. I realize that the 5 has changed into a 4, so that whole 7/7 that is the same as 1 needs to be present in the numerator. If I were to take away 1 whole, or 7/7, I would need to add that to the numerator. Like I said, it needs to be present in the numerator. 2 plus 7 equals 9. Now these fractions are equivalent. For C, I am not sure what is supposed to go here, but I do recognize that the numerator is larger than the denominator, so 8 must go into 11 at least one time. And I know that 8 goes into 11 one time with some remainders. So I know that at least 1 was borrowed from this side. So if we turned 4 into 3 and borrowed 8/8, which is the same as 1, we took away 1 from this side, that 8 needs to go somewhere. 3 plus 8 would equal 11. So 3 11/8 is equivalent to 4 3/8. For D, 6 2/9 needs to be equivalent to something and 11/9. I recognize that 9 goes into 11 one time with some remainder. So if I were to take away 1 from this side, which would be equivalent to 9/9, that 9 needs to be present in the numerator. So to make up for it, so 2 plus 9 would equal 11. That checks out. So my answer that is equivalent to 6 2/9 is 5 11/9. When trying to figure out how many minutes are in 1/6 of an hour, I'm going to keep in mind that 60 minutes is the same as or equivalent to 1 hour. If I'm trying to find out how many minutes are in 1/6 of an hour, I need to divide 60 by 6 or find 1/6 of 60, in which case I would multiply across because of means multiply. So I'm doing 60 divided by 6, which would equal 10. So 1/6 of an hour would be the same as 10 minutes.